Right, I'd like to take you through the calibration process for the LPMS IMUs. I already have the LPMS control program up and running. I have also 2 USB connections to my computer. One that is actually the serial connection. It's the red FTDI board, and then the other connection is providing power to the sensor. The sensor is already plugged in. When you're plugging in the sensor, its power should be disconnected. Once it's plugged in and secured in place, then go ahead and plug the sensor in. For most of the sensors, once they're plugged in, they'll show the blue breathing type behavior. Some sensors don't do that. It's one of those good questions as to why that's the case. All right, so once that is all set up, make sure that the sensor itself is selected as under the preferred devices, and to connect, it's this button right here. This should respond within a couple seconds with connection OK, and you'll see sensor status started. Right now, we're looking at a block that indicates the 3D orientation of the sensor. So now rotating the sensor around. One can also look at the Euler angles and the quaternions that correspond to the sensor orientation. So I typically am looking at Euler angles, or I'm looking at the 3D box position here. Before sensor calibration, want to make sure that the filter parameters are set correctly. From time to time, they get reset on the sensors. We don't know why. The default for filter mode is gyro accelerometer Kalman. It should be gyro accelerometer magnitude Kalman. And many of these are actually default. So it should be dynamic, ultra, enabled, disabled, enabled. And for low pass filter, the default is off. We want 10 milliseconds there. So 0.01. So once that's configured, I typically will save parameters to sensor. Unfortunately, the documentation isn't always clear as to when the documentation isn't always clear as to what the right sequence is. In fact, right now it's demanding that I bring up the magnetometer, I calibrate the mag field map. Typically, the process that I will go through is first to calibrate the gyro. Before this, the sensor needs to be held in place and shouldn't be moving. So it's just trying to calibrate the zero of that gyro. And it doesn't take very long. And then once we're done with that, it's interesting that the program that hasn't been updated is now behaving differently. Now it's demanding that the mag field map be calibrated. Okay, so it is asking for the ellipsoid calibration, which is the correct thing to do. One can also go to that directly by going to calibration, calibrate mag, ellipsoidal fit. So before I start this, I have the sensor sitting in front of me. I'll try and hold it in the camera view so that it's visible in the video here. But what I will do, so it's going to be collecting data over a period of time. What I do for about the first half is I make sure that I do full rotations and then back along each of the cardinal directions. And then I start doing a figure-8 pattern thereafter. So let me go ahead and start that. So doing first rotation and then back, and then rotation along the next direction, and then back, and then the last rotation, and then back. And that's a little bit more than half. That was about 60%. And then the figure-8 shape. Next, it wants to calibrate alignment. For this, you definitely don't want the sensor sitting. Anytime you're calibrating the magnetometers, you don't want to be anywhere near the any sort of magnetic sources. So metal, steel end tables will be a problem. So I'm actually have it sitting on a cardboard box right now. And I'll click next, and it will think about that for a moment. And then calibration finished. I'm not sure. So one can also calibrate the 0, which is probably a good idea as well. So we can set offset, in which case the sensor really should be flat when we do this. And then finally, I do a save parameters to sensor just to be sure that everything gets written properly. And then at this point in time, if we start the sensor off in its 0 orientation and move 90 degrees in each of the cardinal directions, then we should see that same change in the box there. So let's go the other direction. There's about 90 degrees there, and let's go 90 degrees here. I'm not exactly keeping it very flat, am I? Okay, so that is the process. Once we're done, we can disconnect the sensor from the software, and we're good to go. So at this point in time, we can turn off power to the sensor and then remove it from the programming interface.